Alright, next is the titrations curve between strong acid and strong base, but this is different from the previous one because it has different titrants and analyte. Alright, so acid-base titrations is carried out by adding 0.1 molar HCl dropwise to 25 ml 0.1 molar sodium hydroxide. Sketch the titrations curve to show the variations of pH against the volume of HCl added. Right. So HCl is the titrant, so we put that in the B, right? And sodium hydroxide is the analyte, so we put that in the conical flask. So here is the chemical equations. HCl plus NaOH, we get NaCl plus H2O. And this is the titrations curve. pH against the volume of acid added. Okay, so this time the titrant is acid. So there are 4 important points that we are going to be discussed here. So point A is the beginning of the titrations. So at this point, there's only strong base present in the conical flask, and it has low concentrations of H+, and it has high pH value. So the pH is going to be start at around 14 or 13. And then point B is the point before equivalence point after additions of titrants HCl. So when you start to put HCl into the base, the pH decreases gradually as base is neutralized by the added acid. And then as you reach the 25 ml of acid, we get the equivalence point. So point C is the equivalence point. And at this point, there is equivalent amount of acid and base being mixed stoichiometrically, and the pH value is determined by the type of salt formed by the reactions. So it has the same pH value from the previous one, which is equal to 7, right? So the pH of equivalence point is equal to 7. Point D is the point after equivalence point. So at this point, you continue the titrations. You put extra HCl into the base, into the solutions, into the conical flask. So what happened to the pH? The pH will drop slowly because at this time, the concentrations of H+ is higher than concentrations of OH-. So the solution is no longer neutral. Alright, next is the titrations curve for the titrations between strong acid and weak base. Alright, acid-base titrations is carried out by adding 0.1 molar NH3 dropwise to 25 ml 0.1 molar HCl. Sketch the titrations curve to show the variations of pH against the volume of NH3 added. So, at these titrations, NH3 is the titrant, so we put that in the B, right? And HCl is the analyte, so we put that in the conical flask. Alright, so here is the chemical equation. HCl plus NH3, we get NH4Cl as a salt. And this is the titrations curve. We plot pH against the volume of alkali added. So remember that alkali here is NH3, which also called as titrant. Okay, so as usual, there are 4 important points that you need to know what happened at each point. Okay, so point A is the beginning of the titration. So there's only strong acid present in the conical flask, and it has high concentrations of H+ and low pH value. So the pH starts at 0 or between 0 to 1. Right, next is point B. This is any point before equivalent point after additions of titrants. Okay, there is NH3. So as you add base into the acid, what happened to the pH? The pH increased gradually as acid is neutralized by the added base. Alright, so when you put 25 ml of alkali into the conical flask, we get the equivalence point. So this is point C, where the amounts of acid and base being mixed stoichiometrically. And the pH value is determined by the type of salt formed by the reaction. Right? So what's the type of salt that's formed from these reactions? Let's look again at the titrations. We use strong acid and weak base. So we get NH4Cl as a salt, and this salt is acidic salt. So the pH of equivalence point is less than 7. Alright, and point D is after equivalence point. At this point, you continue to add base into the conical flask. So what happened to the pH? So the pH will increase slowly because there are more concentrations of OH minus compared to concentrations of H plus. So at this point, the solutions might be no longer in a neutral. Alright. Next is titrations curve for the titrations between strong acid and weak base. But this is different from the previous one because the titrants and the analyte are different. Okay, acid-base titration is carried out by adding 0.1 molar HCl dropwise to 95 ml 0.1 molar NH3. Sketch the titration curve to show the variations of pH against the volume of NH3 added. So at this titrations, HCl is the titrant, so we put that in the burette, and NH3 is the analyte, so we put that in the conical flask. So here is the chemical equations. HCl plus NH3, we get NH4Cl as a salt. So here's the pH, the titration curve. So we plot pH against the volume of acid added, right? So this time, the titrant is acid. So at point A, this is the beginning of the titration. So there's only weak base NH3 present in the conical flask. So it has low concentrations of H plus and high pH value. Okay, so the pH of weak base is slightly smaller compared to pH of strong base. So the pH is going to be start between 11 to 12, right? Next is point B. At this point, it is a point before equivalence point after additions of titrants. So as you add HCl into the base, the pH decreases gradually as weak base is neutralized by the added acid. Okay. At point C, when the volume of acid that you add into the base is 25, exactly 25 ml, we get the equivalence point. So there is equivalence amount of acid and base at this point that being mixed stoichiometrically. And the pH value is determined by the type of salt formed by the reactions. And it has the same type of salt from the previous one, which is acidic salt. So the pH of equivalence point is less than 7. Point D is the after equivalence point. So if you continue to add acid into the conical flask, what happens to the pH? It will drop slowly because at this time concentration H plus is present in excess. So the solutions might become more acidic. And here, please take note that there is a rapid fall of pH at the beginning of the titrations, but the rate of fall will slow down. So this is related to the buffer solutions. Alright, next is titration curve for the titrations between weak acid and strong base. So acid-base titration is carried out by adding 0.1 molar sodium hydroxide dropwise to 95 ml 0.1 molar CH3COOH. Okay, so and AOH is the titrant, so it's in the burette, and CH3COOH is the analyte, so it is in the conical flask. So the chemical equation is CH3COOH weak acid plus with an AOH strong base. We get CH3COONA as a salt and H2O. So this is the titration curve, pH against the volume of alkali added. So alkali here is sodium hydroxide. Okay, at point A, the beginning of the titrations, only weak acid present in the conical flask. So it has high concentrations of H plus and low pH value. And at this point, pH of weak acid is slightly higher than strong acid, so the pH is going to be start around 2 and above. Next is point B. This is the point before equivalence point after additions of NaOH. So when you add NaOH into the acid, the pH increases gradually as acid is neutralized by the added base. And then when you add exactly 25 ml of alkali into the acid, there is equivalence point amount of acid and base being mixed stoichiometrically. So this is at point C, equivalence point. The pH value is determined by the type of salt formed by the reactions. So what's the type of salt that is formed by these reactions? So look again at the titrations. It is between weak acid and strong base. We get a CH3COONA as a salt. So this salt is basic salt. So the pH of equivalence point is more than 7. Okay, next is D. It is a point at which after equivalence point, so the pH will increase slowly because you continue at the sodium hydroxides. So concentrations of hydroxide ion will present in excess. So the solutions will become more basic. Next is titration curve for weak acid and strong base. So at this time, the titrant is CH3COH, so we put that in the burette, and the analyte is NaOH, so we put that in the conical flask. So it is a different titrants and analyte compared to the previous example. So here is the chemical equations. CH3COOH plus NaOH, we get CH3COONA plus H2O. So this is the titration curve. We plot pH against the volume of acid added. So this time the titrant is acid. So at point A, only strong base present in the conical flask. So it has low concentrations of H plus and high pH value. So the pH starts at 14 because it's strong base. Okay. At next point B. So at this point, this is point before equivalence point after additions of CH3COH. So as you add acid into the base, what happened to the pH? It will decrease gradually as strong base is neutralized by the added acid. At point C, when you add exactly 25 ml of acid into the conical flask, there is equivalent amount of acid and base being mixed stoichiometrically, and the pH value is determined by the type of salt formed by the reactions. So it has the same type of salt from the previous example. So this is basic salt. So the pH of equivalence point is more than 7. Next is D. It is after equivalence point. So this point, as you continue to add acid, the pH will drop slowly because concentration H plus will present in excess.